This video will be packed with information about authentication and authorization, meaning determining who you are and what you can do. I'll create a class on the backend that will house the token handler as well as other security-related methods. Then I'll create a few tables on the server for users, accounts, events, and roles. I'll create some endpoints and DTOs for registration and login before heading to the front end, where I'll be implementing the AuthProvider, AxiosPrivate, as well as other hooks. Then I'll create components and routes for login and registration and create their forms. In the end, I will demonstrate how logins are compartmentalized between accounts and domains. Let's get started. Okay, I'm on the server here and I'm creating the accounts table with all the fields. Somehow I initially thought it was a good idea to mix the account holder data into this accounts table. Just a heads up, I'll be changing this later. Notice each table is getting an enabled, deleted, and created field. Once all the fields are set up, I'm also creating indexes on all the fields that I might search for or use in a where clause later. This will dramatically improve performance when doing queries, especially when the tables are getting bigger. Then I'm heading straight back into my API project. Whenever I make changes to the database, I also have to mirror the changes to the entities. So I'm creating a class called account here that mimics the database. I also decorate the class with key and other field attributes. Finally, I add the account class as a DB set to the right as well as the read contexts. Next, I'm adding the security context to the core folder of the project. This class will house anything security related, so the token will be handled here as well as password encryption and comparison. I inject the DB write and read context as dependency here because I'll definitely need those. Then I proceed by writing the create token class. This class will be essential for our authorization and I'll modify this class in the course of this video quite a bit. Each token has a lifetime and claims. If you are unsure how tokens work, I suggest you watch some videos about JWT or JSON Web Tokens. All these claims are publicly visible when inspecting the front-end JavaScript, so it's important not to include passwords or other sensitive information. The token is then signed, so its content can easily be verified later. Here I'm creating a token DTO class that will essentially contain all the information that is needed later when the user logs on. Besides name and email, it will contain an access token as well as a refresh token. The access token is only valid for 15 minutes, while the refresh token is valid for 24 hours or 21 days, depending on the user selection. The access token will be used to make calls to the API while it's valid. The refresh token will only be used to get a new access token. Next, I'm creating a read token method that takes the token string and converts it back into a token DTO object. This method will also be heavily modified during the course of this video. I'm actually going in reverse and add each claim to the corresponding field in the token DTO class. If anything doesn't validate, I change the new token email to 401, a definite sign for the rest of the code that the token is not valid. I'm adding an issuer and audience here. That's actually not super important for us since the issuer and consumer is the same API. But it's good to add it in case you have other use cases for the project where you might need to validate against other systems. I'm adding the newly minted security context scope to the services builder, so it will be available as dependency in other classes. Next, I'm creating an account controller and inject the security as well as the database contexts into the class before creating a register endpoint that I will use to register an account. For this, I also need to create a DTO that I'll call Register Account DTO with all the necessary fields to register an account. Going back to the register endpoint, I start by validating the incoming data. I also have to test against the database to make sure the domain has not been registered before by someone else, or the email has not been used for creating other accounts before. And lastly, I create a text file called banned domains and add all the domains I don't want to allow users to create. That includes profanity or other words that I have reserved for internal purposes. I loop through these words and return a bad request as soon as I find one. I get ready to create an entry in the accounts table when I realize I have to create a function to build a password hash and password salt first. A verify password hash function will work the opposite way, ensuring that a stored hash will actually match up with the password submitted during the login. With that out of the way, I'll return to the register endpoint and proceed to finish creating a record in the accounts table. This is where I realized I could refactor the token handler so I don't have to reference an account and event each time. With these low-level functions, it's all about performance since they will be called a lot during the lifetime of the application. Next, I create the login endpoint, which is another post call. You can see the power of Copilot here, which essentially writes a big portion of the endpoint. And lastly, I create a test endpoint that needs authorization. This will serve as test to see if the token will actually work, so I decorate the endpoint here with the authorize attribute. Next, I publish the project and test the register endpoint and pretty immediately run into some 500 server errors. I see the record is being added to the database, but the server does not return a token. Also, the GeoID is not being generated, but that is a small issue. I debug the project locally and can see that the key I used is actually not long enough for the hash algorithm, so I extend the key in the app settings JSON. I finally receive an access token and refresh token, but when going to the test endpoint, the token seems to be not valid. I can see that there are problems with the issue and audience. Debugging this took me a good hour. I will fast forward to the end here. There were some settings out of place in the program.cs file. It finally works as expected with issue and audience. As I mentioned before, this is not super important for our purposes, but it might be important for your project. As you can see here, in the end the token validates at JWT.io and contains issue and audience. Now that we have two important endpoints in place, I want to work on the front end a little. In the React project, I create an AuthProvider that will provide context and help authenticate the logged in user to the whole project. I'm also creating a type token DTO that will be used for this purpose. It mirrors the token DTO we have created in the web API. I'm thinking ahead and I'm adding a string array of roles to the token DTO. It will distinguish an admin from an attendee later on. Besides the auth state itself, the AuthProvider will have two exposed functions, log in and log out. I'm also adding an account and event ID to the token. This will provide the ability for an onion scheme later on, where there will be super admins that can access all accounts, account admins that can access all events, and event admins that can access and manage a single event only. If persistence is checked, the token information will be saved to the local storage of the client. Otherwise, session storage will be used. Here I'm building a timer into the AuthProvider. It will go off every 5 minutes and will connect to the refresh endpoint of the API, requesting a new access token and therefore keeping it current. The constants file keeps certain constants that can be recalled throughout the application and helps to declutter the project a little bit. I keep adding items to the token that I want the application to remember with the user. In this case, it's the time zone the user is in. Speaking of time zones, it is easy to determine the time zone through JavaScript, but a lot of people are traveling with their laptop and are attending an event and are not changing their time zone on their computer. Here I'm downloading the Maxmind GeoLite database that will allow me to determine the location and time zone via IP the user is connecting through. Once imported, I'm creating an endpoint init in the auth controller that will return some information about the location and time zone of the user. I'm importing the Maxmind GeoIP2 package here for this purpose. Then I'm creating init DTOs so the information can easily be passed back to the front end. Back in the init endpoint of the auth controller, I keep expanding the functionality of the method, adding the URL as a parameter, which will give me information about the account and event ID, which can be passed back to the front end. This will be important because the user information will be stored in a variable containing the account and event ID. Back on the server, I create an events table in the database. It is more or less a placeholder and won't contain much information for now. The URL, title and subtitle are the only fields pertinent to the event itself that I'm adding for now. Now I'm deciding to deconstruct the accounts table and offload the owner information into the users table. This makes a lot more sense, and I could have saved me some work if I had done this in the first place. Having two places that contain user information sounds like a bad idea in retrospect. I'm fast forwarding here a bit, and moving those fields one by one is tedious work. As always, I'm creating indexes for many of the fields before I forget. I then proceed by removing said fields from the accounts table. Back in the API project, I match both entities account and user with the fields in the database. More tedious work that could easily have been avoided. If this process seems a little chaotic to you, it probably does because it is. It's part of the rapid prototyping approach that somehow works for me but might not work for everyone. I'm also adding the entity event for the events table that I've created, which will then also be added to the DB set of both read and write contexts. And finally, here I'm removing the list user endpoint from the previous video that was spitting out the whole users table and would cause a serious security issue going forward. I'm going back into my init endpoint, and now with the table in place, I can determine the event ID from the URL that has been submitted. With all the changes being made to the account and user tables, I now have to deal with things not lining up with the token functions anymore. So this will need to be reconstructed also, which I'll quickly time-lapse through here. It's a fairly simple idea. The accounts table has a field owner ID that will point directly to a record in the users table. I'm making the necessary changes in the register endpoint for now, just so the compiler does not throw an error. I'll have to revisit this endpoint again before the video is over, but the idea here is to create the user, then to create the account with the owner ID and user, then go back to the user to add the account ID into it. Normally this would be a task for a transaction with a stored procedure, but I want to keep things relatively flexible for now. I clean up all the loose ends and the project compiles. Here you see me using a join over two tables using link. I like how link allows you to basically write SQL while maintaining an object-oriented approach to the entities in use. I comment out most of the register endpoint. As I said, I'll have to revisit this again very soon. As I'm debugging, I realize there are problems determining the location. I initially suspect the assembly not posting the correct path to the Maxmind database, but it turns out that the IP being used for debugging is 0.0.0.1. So I publish the project to the server and it works as expected. I manually enter a test event in the database on the server, and testing the endpoint with test comes back correctly with event ID 1. I expand the events table here with a field time zone. There will be more fields added down the line. I also have to make the changes to the entity as well as the token DTO, as I'm sure having this information about the event time zone will be needed. I'm actually adding both the IP time zone and as well as the event time zone so the client can access both. This information will be available not only when the user logs in, but when he first comes to the page. So I'm adding it to the init endpoint. Next, I'm adding another table, nodes, to enable multi-server, multi-data center and high availability deployment. It will list all nodes that are active and available. It will also give geolocation, so a user can automatically be directed to the nearest server for the API calls. I'm populating the table with two records for testing. Both domains are pointing to the same IP for now, but our system does not know that. I'm pretending to use one data center in Denver, another in New York. Going back to the auth controller, I first need to install the GeoAPI coordinate systems package. It simplifies calculating distances between two geo coordinates. Then I add the node class to the entities folder, so I can leap through the nodes and calculate the client's distance to each server. I then return a sorted and unsorted array of nodes. The sorted array will have the nearest server in first position, while the unsorted array will have the first server in the table be returned first. Eventually I'll need both arrays on the client side. The debugger throws an error. I had mixed up longitude and latitude in the database when populating the server's coordinates, so I swapped them and it works. Back in the front-end project, I add the type init DTO to the list of types so it matches the server's response. Then I modify the use effect routine in the AuthProvider. I want to make a call to the init endpoint and make the information that comes back available to the context. I log the results and surround the app with the AuthProvider. This does not work right away. I'm modifying the get call a bit, then I go back to the web API project and decorate the auth controller with the version information. Back in the front end, I need to pass the URL into the get call to the init endpoint. I first try the use location hook from the React router DOM, but this does not work. I decide to go the direct JavaScript route and query the location using window location path name. And as a result, the console spits out the init DTO from the init endpoint, a major milestone as I now can recall and save data according to the account and event that is being accessed. I modified the type token DTO so it matches the token DTO on the web API. Then I add an empty token to the AuthProvider that will be the placeholder until I receive information either via init or login from the server. After a successful init call, I'll move certain fields in and out of local storage or session storage. I create a file called axios.ts in the lib directory. It will house the base extension to Axios, as well as AxiosPrivate with the hooks necessary to send the authorization header with the access token from the AuthProvider. The hook use AxiosPrivate will have a request intercept in case it receives a 401 access error. This intercept will then make a call to the refresh endpoint to get a new access token before trying the original call again. This should work all seamlessly behind the scenes. So naturally, it is now time to create the refresh endpoint in the Web API project. This endpoint will be called a lot depending on your expiry window of the access token, so it's important to keep this call efficient. I realize that in order to log in, I not only need the username and password, but also the account and event IDs. So I'm making the necessary changes to the login account DTO and completely rewrite the login endpoint. I change the email to username and finish validating the entries of the user. I populate a token DTO with all the necessary fields from the account, event and user tables. Then I realize that the nodes and GeoIP functionality is needed in several places, so I'm writing a helper function, getIPinfo, that returns a tuple. It can be accessed both from the init as well as the login endpoints. I'm also adding the helper class scope to the service builder and proceed injecting it as dependency into the auth controller. I now can modify the init endpoint, making full use of the getIPinfo helper function. Going back to the login endpoint, I also use getIPinfo here when populating the token with information. I make the validation length of the token dependent on the choice of persistence coming from the client. Back on the server, I create another table called user roles. The users table will have a one-to-many or even zero-to-many relationships with this new user roles table. After creating the matching entity, I don't add the roles to the token right away. I refactor the call to create token instead first, so I don't have to make separate calls to the accounts and events tables in different places. I also have to replace references to emails everywhere that have been replaced by username. Refactoring the create token call also requires me to change the refresh endpoint. I'm debugging the project here a bit so it compiles. Swagger is a great tool for testing the endpoints before actually moving on to the front-end code. Some prefer Postman, but having a built-in test tool for the endpoints definitely comes in handy. Here I'm testing the login functionality with the account I just created to make sure each account has its own domain. Okay, back in the front-end project, it's time for some routes. For this purpose, I'm creating the file layout.tsx. In terms of functionality, it will take over for app.tsx, so I'll have the theme provider with a dark theme here, the header, a special component outlet, as well as a footer. Outlet will act as placeholder for the routes component. The app component, on the other hand, will be used to determine the routes of the application. So in case the start component in routes here and tell the app to use the layout as overarching frame for the routes within. My start component from previous videos will be set as index element in the outlet of the layout. Next, I'm creating simple register and login TSX files. I'm using the React functional component snippet of my plugin to create the simple boilerplate. Then I add an h1 tag with the component's title inside the return of each component, just as a placeholder. And finally, I add routes for these two components inside the app.tsx file. I test out this functionality in the browser and the correct component shows up for both routes. Now I'm going into the header.tsx file that I previously worked in for the socket connection. I'm creating two buttons to the very right of the header bar for login and register. I'm styling this page using Tailwind CSS here, and it becomes obvious that my skills in Tailwinds leave something to be desired, but I finally managed to line everything up. Then I go into Tailwind config.js and add the main colors that I'll be using for this project. These colors actually belong into theme extend colors, which I'll find out quickly as I essentially have removed all other colors from the working project. Then I add some other attributes to the class of the login button, and slowly the button is taking on the correct shape. I do the same with the register button. Finally, I add on click handlers that fire when each button is clicked. I convert the buttons into links, but Tailwind is losing some of the styling here, so I go back to the original button idea and add the use navigate hook inside the onClick handler, and just like magic, each button brings up the corresponding route and component. Now I'm going to style the login component, which is the easier of the two forms here. I don't want it to span the whole way, but be a maximum of 400 pixels wide. As I'm styling the header here, you can see Copilot is predicting what I'm trying to do and suggesting a form completed with email, password and submit button readily styled with Tailwind CSS. All I have to do is add the Remember Me checkbox, change the email to username and add some placeholder values. Next, I add a use state that holds an object of type login account DTO, which holds all the values of this form. Whenever a text field or the checkbox changes state, the value of the object will change. Then I add value and onChange handler to the input fields and the checkbox. Note the checkbox logic that changes a value between 0 and 1. Now I add a useEffect hook with dependency on my data. It will log each time the state changes, so basically with every keystroke in a text field, just to test out the functionality. Everything seems to be working fine, I'm just changing the size of the box a little. Then I add another useEffect hook with dependency on auth. So if the state of my AuthProvider changes, so do the account and event IDs in my use state that will be submitted to the login endpoint. You can see in the console that the account ID of 4 and event ID of 1 were pulled into the object of the useState variable. Now I'm going back to the header file. First I change the text to the left to be clickable. It will lead back to the start.tsx page. Next I pull useAuth into the header and query the ID of the auth user, so I only show the buttons login and register if no user has been logged in yet. Otherwise it will show the logout button. Back in the login component, I write the function of the onSubmit handler of the form. All I have to do is take the useState with the JSON object and send it as form via Axios to the login endpoint. If the request returns a status of 200 OK, I can send the whole token DTO that is being returned to the AuthProvider via login function. I try to get the form not to use the default behavior in refreshing the page, but TypeScript makes it surprisingly difficult. In the end, the event variable was of type React form event of HTML form element. This took a couple of Google searches where even Copilot led me down the wrong path. The login functionality did not work right away, but after a few minor modifications, the endpoint finally returned the token DTO, which was saved in a variable on the local storage of the browser. It then changed the login and register buttons to the logout button, as expected. Here you can see the variable user 40, which denotes account 4 and event 0. There is also a session variable stored with the same name. Next is the register component. I'm making the box to register a little wider to accommodate for more form fields. I'm adding an onSubmit handler and a matching empty function here. This is where I'll submit the form to the web API. I'm adding a JSON object myData with type register account DTO that will store all the data for this form in a use state. This type needs to be created first, so I'm adding it to the types.ts file. The first form fields I'm adding is the domain and the submit button. You can see me here adding text to the beginning and end of the text field, as I want people to just type in the subdomain itself. You can see me changing the padding so it's just right. I'm also adding an icon to the end of the field to indicate that the subdomain is correct and available. Attention to detail is important here. I want the UX design to be as useful and intuitive as possible. Next I'm adding an email field. I'm deciding on all input fields to have a small indicator at the end. All of these fields are getting corresponding values and onChange hooks, so they are functional right away. Now it's more or less rinse and repeat, except that these next two fields, first and last name, are sharing a line if the screen allows for it. The same goes for password and repeat password. An extra surrounding div and a few classes, and Tailwind CSS takes care of the rest. I change the text in the button from login to register, change some minor styling, add icons in all the fields, and change the placeholder in the form fields to finish the styling. Back in the web API, I need to add an endpoint that can be queried if the domain is available or not. I'm using a simple get call to domain available. First I'll do a bit of validation to make sure the string is in the right format. I'll allow for upper and lowercase letters, numbers, hyphens, and underscores. I'll check if the domain has been registered by someone else first, before looping through my trusted text file of banned domains, that's last line of validation. Any hits will get a bad request, otherwise the endpoint returns a 200 OK. Going back to the front-end form, it is now time to implement this feature. Handle domain check will make the Axios call, and depending on the return, the icon will change to a checkbox or a red stop icon. Finally, I use the hook onBlur to call the function, as I don't want this to be called on every keystroke. I intend to put this endpoint behind a rate limits later. I'm also adding another useState check that contains an object with all the fields checks before the submission of the form will be possible. This object will also contain the reason the domain might not be allowed, which will be pulled from the returning bad request response. As usual, TypeScript is giving me a hard time, but it will lead to a better code base down the line. Now it's time to implement the icon changes, and the object in the check state turns out to be very helpful here. I'm adding a tooltip with the text of the error, but the tooltip seems not to be working with the CSS from Tailwind inside the form field. There's a lot going on here, and this is not simple HTML markup anymore. Tooltip wasn't built for this, so I'm abandoning this tooltip plan altogether. I'm testing the domain functionality here with domains that are registered already, available, as well as banned via text file, and all seems to be working. Next, I'm writing a hook with dependency on my data, so if anything changes in my data, this hook will be called. It contains all the checks to all the form fields. For this reason, I need to add regex tests against name, email, and password fields. The password requirements can be as elaborate as regex allows for it. What's important is that this test matches the validation test in the endpoint of the web API. As you can see, depending on the regex test, the values in the check states are set to true or false. I enable or disable the submit button as well as change the class of the button based on the checks object. Then I go back and add a clue text field to the object. It will contain the reason in the text form for the last check that failed. I now need to populate this text field depending on which field has failed, and finally I'm adding this field to the form itself depending on whether there's text in it or not. I'm making some styling changes to the button and check out the form, which seems to be working okay. It doesn't submit anything yet and most icons are not changing yet, but the clue comes up correctly. So now I'm actually changing the icons depending on the state of the checks object. I save the file and test the page again just to see that the green checkboxes are showing up correctly now depending on the input data. The register button also turns green when all the fields are valid. I'm adding the module Toastify to the project. It's a really nice way to notify the user something has been successful or if it has failed. Back in the project, I add the toast container to the page and have the handle submit show a simple toast message. Wow, so easy. Finally, I style the box and behavior of the message a little bit so it fits the theme of the page. Here I'm adding the Axios functionality to the page that will actually submit the form to the server and register the domain and user in our database. I'm adding a simple toast success at the end. In another video, we'll expand on this and direct the user to a page to validate their email address. This video has been long already and it will have to do for now. I'm testing the form submission and in the usual fashion it does not work right away. But I'm not being discouraged and make some changes to the code. I clearly mixed up the logic of the or not calls here to the checks object. After making the changes, the form submits to the register endpoint. On the server we can see the new records that were created in the database, and finally after changing the domain, I'm able to log in with these new records using the login form we created earlier. I add the username next to the logout button to visualize that the system keeps track of different accounts depending on which subdomain I'm in. With that, we've laid the groundwork for a multi-domain and multi-role event management software that is scalable, secure, and has real-time capabilities. In the next video, we'll start on a standalone app that will interface with printers, displays, cameras, and other devices.